Let's look at part 4 for the stoichiometry test review. Again, these are some random questions that are really very similar to the ones that are going to show up on the assessment. So we got a little diagram one, the limiting reactant. And again, the limiting reactant really tells you how much of the products you can form. You can only form as many products or as much of the product as the limiting reactant, and that's really the key in these problems. And you really got to look at, especially when you start doing the problems, look at which one is in the least number of moles when you do a 1-to-1 molar ratio. But first of all, we got this one. Aluminum reacts with oxygen gas to produce aluminum oxide. Gives us the equation, and it says to sketch 10 atoms of aluminum and 6 molecules of oxygen gas in the container, and in the right, sketch the contents after reaction is complete. Well, aluminum oxide, if we look at this, it takes 2 aluminum atoms combined with 3 oxygen atoms to produce aluminum oxide. So I just used dark ones to represent. I got 10 atoms of aluminum and 6 molecules of oxygen gas, which is really, if you think about it, this is going to be 12 atoms. And so aluminum oxide is in a ratio of 2 aluminum to 3 oxygen. So what I did, I just started putting the product together. So I get 2 aluminum and 3 oxygen, 2 aluminum, 3 oxygen. Well, notice I've used 6 oxygen atoms, 2 aluminum, 3 oxygen. I used 9, 2 aluminum, 3 oxygen. There's my 12. So I used up my 12 oxygen, and 2, 4, 6, 8. I used 8 aluminum. So I have 2 of the aluminum left over, which is an excess. So my limiting reagent's got to be the O2. Because I still have some excess of the aluminum that left over. How many atoms or molecules? The excess, and it's 2 atoms of aluminum. So that's how you do that problem. And again, it's just kind of more of a visual way to do a limiting reagent problem. Alright, so let's look at a problem once. If 21.4 grams of aluminum, go ahead and let's write the formula. I always got to start with that. Is reacted with 91.3 grams of iron 3 oxide. So, iron oxide. The products will be aluminum oxide, ALO, and iron metal. Alright, so we got to go back and put in the charge. Our free elements are always 0. And iron, it says iron 3, so we know this is 3 plus, this is 2 minus. Aluminum's actually 3 plus. And oxygen is a 2 minus. So let's go ahead and do the crisscross. So we got to get the formula. So Fe2O3, Al2O3. And make that a little bit better. So now I've got the formula balanced for charges. Now I got to come back and balance the formula for the number of atoms. Well, let's see. 1 aluminum, 2 aluminum, so we know we need that there. 2 iron, 1 iron, we know we need that there. And I think we might luck out here. 3 oxygen, 3 oxygen. So what we have is the balanced equation. I'm going to rewrite this so it's a little bit neater. So 2Al plus Fe2O3 yields aluminum oxide plus iron. So that looks a little bit nicer. Alright, well, we've got the 2 reactants, so we got to determine which is the limiting reagent here. So guess let's start with the first one. I got 21.4 grams of aluminum, and I got to get that to moles. So 21.4 grams of aluminum over 1, and 1 mole of aluminum is 27.0 grams of aluminum. So that gives me 0. Let's see, make sure I'm on the 0.792 moles of aluminum. Well, let's go ahead and find the molar ratio right off the bat here. So we have in the balanced equation, we got to get this, see what 1 is. So we have 0.792 equals 1 to x. 2x equals 0.792. So therefore, x is going to equal 0.396. Alright, so this is really the moles of aluminum. So now we need to do the same thing because we're also given iron oxide. So let's go ahead and do the same thing. Because we've got to get that 1-to-1 comparison. We can't work anything unless we get the 1-to-1 comparison. Let me push this up a little bit. Alright, so let's work with, we have 91.3 grams of iron, 1.3 grams of iron 3 oxide, Fe2O3, that's over 1, and 1 mole, and I'm not going to rewrite it on this particular line here, is 159.7 grams, and if we do the math here, it comes out to be 0.572 moles of Fe2O3. Well, let's look at our coefficient in our balanced formula. Oh, it's already 1, so that's cool. So aluminum is 0.3.
Sorry, I don't know that one.
Alexa just popped in. So aluminum is 0.396, and iron is 0.572. So here's our 1-to-1 comparison. So right away we can see that it looks like this is going to be our limiting reagent. This is our limiting reagent. You've got to have that 1-to-1 comparison. You can't do the problem really until you get to this 1-to-1, because you can't look at these numbers here, because this is just telling you how much is there. But once it's 1-to-1, then you're golden. And the reason we could use this one is because the coefficient is 1 there. So now we can go ahead and do the BCA. So the before, we used 0.792. So we can go ahead and put that in there. So we have 0.792. Iron, we have, this is what we're given now. This is what we're given. We're given this much. So we need to put that in there. 0.572. Because in reality, this is going to be the excess reagent. We don't know what that is. Alright, so we're going to use all of this up. So let's go ahead and put this in as 0 here. Now for the iron oxide, this is what we're given, that this is the limiting, this is going to be an excess. So what we're really going to use, we need to go back to the limiting reagent molar ratio, which is 1 is 0.396. So where you see that this definitely is going to be in excess. And this is the key. You can only use up what the limiting reagent is. You just have this is going to be, there's going to be some extra there. So you're just going to use up the amount that is dictated by the limiting reagent. Likewise, you can only make the amount that is dictated by the limiting reagent. So we can look at this. We got aluminum oxide has a coefficient of 1, so that's going to be 0.396. Nope, I forgot to put the other 0 up there. And the iron, there's 2 of them. So 2 times this is going to be 0.792. 0.792. Everything is based off this limiting reagent. This dictates everything. So that's why it's so key to find that one out. This is limiting, that's going to be in excess. Alright, so then the question asks, what mass of iron will be produced? Alright, here's our iron right here. Looks like we're going to have 0.792 moles of Fe over 1 times 1 mole of iron is 55.8 grams of iron. And I'll just bring it down here. Should be end up being 44.2 grams of iron. This is going to be our final answer. But again, you've got to get this 1-to-1 comparison between the two reactants. You can't do it with the amounts that are given because it's a 2-to-1, so you got to get it to where it's 1-to-1, and everything is based off the limiting reactant. Alright, so that's it for part 4, and we're going to have one more part.